All right, if you did not get a chance to finish writing the notes in class, we'll start from where we left off. So it says, if you were to select marbles from a bag and you did not replace it, there are only 14 marbles when you make your second selection. These events are called dependent. Like we talked about in class, dependent means that they do affect each other somehow. Dependent events are events that influence each other. The occurrence of one affects the probability of the second. If you don't have these notes written out, press pause on the video and write them out. All right, we have a rule for the probability of two dependent events. If A and B are dependent events, then the probability of A and B equals probability of A times the probability of B after A. Now that might seem a little bit confusing, but think back to the marbles example we did. It was the probability of A times the probability of B. Here, because we're talking about dependent events, we would be talking about the probability of A multiplied by whatever's left in the marble bag. So you can think of it as the probability of the first event times whatever's left over for the second event. Go ahead and write that out. All right. Suppose you choose marbles from the last example. Again, in the top left corner, I wrote out the marbles for you. There's 4 blue, 3 red, and 8 green for a total of 15 marbles in the bag. What is the probability that you will choose a blue and then without replacing, you'll select a red as the second marble? So again, this is an example of dependent events because at first we start with 15 marbles in the bag, but we lose a blue marble because we're asking, what if you choose a blue and don't put it back? Then you choose a red. I have the problem set up for us below. You can see that there's a multiplication symbol right here. The reason is that the formula is probability of A times pretty much whatever's left over for the probability of B. What would be the probability of A? Choosing a blue. Well, we know that there are 4 blues and there are 15 total. So probability of A is 4 over 15. Now we're going to multiply by whatever's left over. I did have 4 blues, but now I only have 3 left over. So this is why they're dependent events. I don't anymore have 4, I now have 3. I have 3 blues, 3 reds, and 8 greens, which means I have 14 marbles total. How many of those are red? Well, 3 of them. So I have 3 out of 14 as my second probability. Again, from the formula on the last slide, we learned that the probability of 2 dependent events is the probability of the first one times the probability of the second one. When I multiply these out, 4 times 3 is 12, and 15 times 14 is 210. So I get 12 over 210, but that's not the reduced answer. I would then need to simplify, and I would come to a final answer of 2 out of 35. That would be my final answer for the question, what's the probability of choosing a blue, then without replacing, selecting a red. Alright, we'll do 2 more examples. Suppose you choose 2 numbers from a box with numbers 1 through 10. Now what I mean is that there's one of each, so there's a 1, a 2, a 3, a 4, and so on. Without replacement, find the following. What is the probability of choosing a 1 and then choosing an odd? Remember, this is an example of dependent events because they affect each other. If we pull out a number and then we don't replace it, now there's less numbers in the box. Alright, so back to the question. Probability of choosing a 1 and then an odd. The probability of choosing a 1, well, there's only 1 out of the 10 numbers. So that's 1/10. times, because that goes back to our formula, probability of A times probability of B. Well, the second thing is asking what are your chances of choosing an odd? The only odd numbers left are 3, 5, 7, and 9. There's 4 odd numbers left. And remember, we already took out a 1, so now there's only 9 numbers in the box. So our probability is 4 out of 9. Let's review what we just did. We decided that there was a 1 out of 10 chance for choosing a 1. And then we thought, okay, well now there's only 9 numbers in the bag, 4 of which are odd. Those 4 numbers are 3, 5, 7, and 9. So right now I have a 1 out of 10 times 4 out of 9, which equals 4/90. Now that's not a reduced answer, so I'm going to simplify by dividing by 2, and I get my answer, which is 2 out of 45. Alright, I want you to try the next one on your own. Probability of choosing a 6, and then choosing an odd. Now, this is still dependent events, because we are not replacing. One thing I want you to keep in mind is that there are 10 numbers in the box, you choose one, and then there's going to be 9. What I want you to do is press pause until you're done working out the problem. Alright, now let's go through the problem. The first one is picking a 6. Well, there's 1 out of 10 that are a 6, and then we're going to multiply that by the second probability. This changes a little bit. We see that the problem started the same as the last one, but now there are 5 odd numbers. There's a 1, a 3, a 5, a 7, and a 9, which is 5 out of the 9 left, for a total of 5/90, which means 1 out of 18. Alright, if you're still confused about dependent events, go back and try to watch the video again or send me an email. Other than that, you are now able to do your homework, so have a great night.